Assalamu alaikum dear students. I hope you all are doing well. This is your tutor Ms. Javeria Hamid and I'm back with my another lecture. I hope you all understand previous lecture that I have uploaded on 15th of July. Now let's have a quick review what we have done or what we have studied so far. We have studied regarding the dot product or scalar product. First of all, there are two types of products that are in front of you. First one is scalar or dot product, while second one is vector or cross product. Now see their definitions and the difference between them. Scalar or dot product is basically when two vectors multiply in such a way that their product, their result, their answer is a scalar quantity, then it is said to be scalar or dot product simple. While vector or cross product, if two vectors multiply in such a way that their result, answer or product is a vector quantity, then it is called vector or cross product. Here the example of vector or cross product is force into momentum, that is basically a torque. Answer or result is torque. And if we see or look at the example that force is itself a vector and again momentum is a vector and their answer is again a vector, then it is called vector or cross product. Similarly, look here that for scalar or dot product, the first example is work done. Work done is equal to force into displacement. We already know that force is a vector, displacement is also a vector quantity. But when both multiplied in such a way that their answer is a scalar or their result or their final outcome is a scalar quantity, then we call it is a scalar or dot product. Another example of it is power. Power is what? Power is a scalar quantity, not the vector quantity, keep in mind. It is a scalar quantity. So when force is a vector and velocity is a vector, when both vector multiply in such a way that their answer is a scalar product, then it is said to what? It is said to your scalar or your dot product. Here look at the quick example that I have given, that if there are two vectors A and B and they are making a certain angle between them, if you are talking about scalar product, then we do write it as A dot B, that is equal to AB cos theta. It is its what? Its formula, or you can say that it is its mathematical notation or term. Now the question arises, why we are putting the dot between both of the vector. Students, there are many ways to represent multiplication. The first one is simply cross, second one is dot, or simply if we do not put anything between them, then again it means what? It means multiplication. So here we took this way dot to represent the scalar or dot product. I hope you understand the quick review that I have given so far. Now we are moving forward towards our today's lecture, that is the same one or the same topic that we are doing. We are continuing the same topic. Now we are seeing the first example, that is a scalar quantity, that is work done. Students, if dot removes between both of the vectors, there comes a cos theta, that is its formula. As I have just said, that as it is a dot product or scalar product, so whenever dot removes, the formula or your mathematical equation looks like this. Now we are coming over the three conditions that we have. There are three conditions. What the conditions are? Now these two vectors, force and displacement, depends on what? Depends on theta. Now what we are taking or seeing only regarding three vectors, right? Three angles, three thetas right now here. The first one is when theta is 0. Second one is when theta is 90 degree. And the last one is when your theta is 180 degree. Now look when or how the three conditions work on this work done, or how it affects the work done. So the first one is your when the theta is when your theta is 0. I just put here theta is 0 degree, so cos 0 is equal to 1. Keep in mind, cos in trigonometric, cos 0 or cos 0 degree is equal to 1, and there is not any maximum value except 1. So whenever we put cos 0, whenever we put theta 0 between, or in work done formula, we got the maximum work done. How? Look at this. Work done formula is equal to fd cos theta. We are putting theta that is equal to 0, and cos 0 is cos 0 is 1. So it becomes what? It becomes simply fd. Now 0 degree means, another mean is that both the vectors are parallel. Keep in mind, whenever there is theta 0 between any two vectors, that means both the vectors are parallel and cos 0 is equal to 1. And whenever there is cos 0 or theta 0, that means the work done is maximum. Now the second one, when your work is minimum or 0. How? It looks like a typical one, but it's very easy, that sometimes your work done is minimum or 0. I'm just giving you a like real life example, that whenever you are applying some force in such a way that your work is not doing, like there's not any work done, at that time the work done is 0. For suppose, if there is an angle 90 degree between your table and chair, or you are simply applying force and your table or your chair is not moving, that means at that time the work done is 0. We will continue the same example, or we will learn the example that I have just given in detail in the later lectures. Let's just focus when your work is minimum. Okay, whenever your force and displacement are perpendicular, at that time their angle between both of them is 90 degree, at that time your work done is minimum or 0. Why? Because your cos 90 is 0. Let's look at the formula and put the value. fd cos theta, put theta equals to 90 degree and 90 cos 90 is equal to 0. At that time your work done becomes 0 or minimum. Keep in mind, students, that in this condition, when theta is 90 degree between these two vectors, at that time your work done will always be minimum or 0. Now the last and third condition, that is when the work done is negative. How could it be? It could be how? Whenever your work done will be negative, whenever your force and displacement, both vectors are in opposite direction, or making theta 180 degree. Cos 180 degree is equal to -1. Whenever we put the value in the formula, let's put theta is equal to 180 degree, cos 180 degree is equal to -1. When you put -1 here, at that time we got what? We got work done as negative, that will be equal to minus fd. So keep in mind, whenever theta is equal to 180 degree, at that time your work done will be negative, and between both the vectors the theta is 180 degree. I hope you all understand these three conditions: whenever your work done is maximum, when your work done is minimum or 0, or when your work done is negative, or simply the vectors are opposite. I hope you understand the lecture. Please do like, share the video with your friends, and do subscribe the channel. Inshallah, I will meet with another lecture. Allah Hafiz, till the next video, till the next lecture.